round two. So this is the Smart Buildings Academy podcast with Phil Zito, episode 449. And welcome. In this episode, we are going to be going through BAS Point Objects. So thank you all for being here. And everything will be available at podcast.smartbuildingsacademy.com/449. I'll try to do a post edit and pull off all that sound garbage that was going on. I don't know what the heck was going on with that. I'm actually going to turn up the volume just a little bit here. Listen to this. Make sure everything's going good. Yeah, that sounds good. All right, so let's get started. As always, by the way, if you find this valuable, besides for the total cluster that was the initial start of this, definitely leave us a 5-star review. I promise it'll get better. And like and subscribe on YouTube and hit that review button on iTunes and Spotify. Those of you who are listening after the fact, you're not going to be hearing all this snafu. Okay, so point objects. Let's dive right in. I'm going to share my screen. We're going to go right into some point objects. This is a common area that I find folks struggling with when they first start in building automation. They're trying to really figure out points. And we're just going to look at point objects. We're going to look at largely logical objects. And then I think next Wednesday, we will actually bring a controller online and we'll look at point configuration. We're either going to do that or we're going to look at backnet trunks next Wednesday. It'll be one of the two. But when it comes to point objects, there's really kind of three types of point objects. While I'm showing you Niagara, I do want to let you know that these point objects may be named something different depending on the actual software you're working with. And I'm paranoid. I'm going to check my sound just one more time. Okay, everything sounds good. All right, so let's dive in. As I mentioned, you've got a couple different point types. We're going to throw these up real quick. We're going to call them Boolean, numeric, and enumerated. I'm not going to dive into string because string, while it's in Niagara, it's not really in every other building automation system. But we are definitely seeing Boolean, points, numeric, and enumerated. And what I will do actually for you is I will put binary, I will put analog, and then for enumerated, I will actually put multi-state, because for some of you, depending on what the building automation software you're using, it may be called binary, analog, multi-state. So the first thing we notice with these objects that are right here, like if I click into the Boolean point, there is no priority array. There is no way for me to really go and change the object. What you will know in Niagara, we have something called facets. This is called a bunch of different things in different manufacturers, as well as different protocols. So you may have unit type. If you're working with lawn, it may be called snivets. But you can actually go and change your facets, right? So we have the true text, and this is true false, but we can actually have a variety of different facets, which we're not going to get into too much here. But suffice to say, when you are going and setting things up, like I'm just going to give you an example: on, off, start, stop. And oftentimes there will be a table that you can pull from for your point objects, for the unit types, or for, in the case of lawn, snivets, things of that nature. But what this does is this is a binary object or a Boolean object, depending on what manufacturing software you're using. So we're going to focus in on this real quick. This Boolean object or binary object, it just means it has two states. It either has a true state or a false state, and we see that right here. But by doing facets or unit types or snivets or whatever you want to call it, by picking those, what you actually allow to happen is the true false remains the same, but from a user perspective, from a visualization perspective, it makes more sense because your average operator may be coming along looking at something. They may not know what false means. They may not attach, like, oh, fan command or fan status false. What does that mean? Does it mean that the points failed? What does it mean? But if I go in here, right, and I say on, off, and I go back, yes, what we're going to notice now is that this is going to be on, off, right? So it makes a little bit more sense. You could even say like running, not running, started stuff. I really recommend, if you're working with a customer, you get a standard for your metadata. We're working with a community college right now, and it seems like every point has a different unit type. So there's not standardization across the board. And that causes a lot of issues for their operators from just a reporting perspective and analysis perspective. So getting a standard up front, this would be very helpful. But right now, you'll also notice something about all these points. These points have no priority array. We're going to talk about what priority arrays are in just a little bit, but they have no priority array. So what happens, and like I said, in a future episode, we're going to go through point configuration, but I would map a controller point to a point on the wire sheet, usually through, something like adding a controller and then discovering the points and adding those discovered points onto the wire sheet. Actually, they should show up on the wire sheet automatically, depending on how it's set up. But those input points, you're not going to be able to change them. Now, I know some of you are like, Phil, I can change them in ABC's software. And you're absolutely right. In some manufacturers' software, you can do out of service, you can do test, and you can override a input to a actual value, but that's just a test perspective. It's not something I recommend. It makes no sense, because if you need a variable output that you can control, that's where we should move into something else, which I'm going to add our next point here. And we're just going to call this binary value. And you're going to start noticing some things here. You're going to start noticing that it has a variety of other inputs. We're going to call this analog value. And then we're going to add this right here. We're going to call this multi-state value. Now, what do you notice? You notice a couple things going on here. For one, we have what is called a priority array. So if I actually went here and let me move this out of the way and I click pin slots, I could actually select all 16 bits of the array. Some manufacturers are going to use a 0 array. Others are going to use a array that starts at 1. Typically, it is going and starting at 1 and going to 16, but some will go 0 to 15. But what you notice right off the bat, this is what's going to confuse folks. This is either going to be a logical point, meaning it only exists in software, or a physical point, meaning that this is linked to some sort of, maybe it's a 24-volt output that goes to energize a coil on a relay. In the case of analog value, maybe it is a 0 to 10 volt output that goes and connects to the DC portion of a actuator to give it its control signal. But you're going to notice, regardless, these objects look similar, right? Our binary value and our binary output look similar. The only difference is binary values, by default, a value, an analog value, binary value, multi-state value, should be a logical point and should not be linked to a physical device. This becomes really important when you start to do integration. You bring in a backnet chiller, you bring in a Modbus boiler, whatever. Actually, Modbus is a bad example because they use registers and coils. Let's just stick with BACnet. So you bring in a BACnet chiller, you bring in a BACnet boiler, and you would get binary inputs. Those are physical inputs. Those should be the temperatures, the statuses, and then analog inputs. Those should be the temperatures, the pressures, etc. Those are read only. I've seen a lot of people who map these things in and map these points in, and then they're like, why can't I change anything? It's because you're mapping in inputs. Values should be set points. These should be logical software points. So in the case of binary values, this may be a economizer enabled. So if the unit has economizer, you command that BV on and it tells the unit to run like it has an economizer. Analog value, maybe that is a set point for your chilled water supply temp. And so that's a analog value. And then multi-state value, maybe you have a chiller and you want to pick between summer mode, winter mode, off. And so you have a multi-state value and you can give it a 1, 2, or 3, and those correspond. And when you actually get into multi-state values, if we go in here, you'll actually see that you can build a range. Actually, I'm not going to build that here but what you can do is you can actually build a range right here. So we can start to go and add out 1 equals occupied, 2 equals unoccupied, et cetera, et cetera. And what that'll allow us to do is when we have a 1, it will equal occupied. When we have a 2, it'll equal unoccupied, et cetera. And that is more so for visualization, so you know what you're commanding when you command those points. Let me zoom back in. Pretty straightforward so far, right? So we've got inputs that are non-writable. We notice they do not have a relinquish default or a fallback value, which we'll talk about in just a second. We have values. These are software logical points that are writable. And then we have outputs. These are typically physical points that are writable. How priority arrays work, this is a concept that is not exclusive to BACnet, but is well known for being a BACnet property, is a priority array. And a priority array exists so that if I write to input 16, right, which is typically global write, and I write to 8, which is typically operator override, 8 is going to take priority over 16. And then my fallback is if I have nulls in my array, then I'm going to fall back to whatever the fallback value is. So if actually a better way to show this would be, and I don't think it's going to show because this is offline, but we'll see. I don't remember correctly if it's going to show or not show when it's offline. But if I go in here and I set my fallback value, not null. So null is not 0. Null is nothing. 0 is a value. Like if I save this, right? 0 is my value. So my output is 0. My output, if I get rid of this and I go back into it and I make it a null and I save this, then, I mean, it should, as soon as something writes to it again to clear it out, go to null. So right now it's got that locked in at the output. But what you're seeing right here, that is a completely different value. Null is nothing. 0 is something. That's a very important concept to understand. But if I go here to 62, and then I go back and I create another analog value right here, and we just call this analog value 1, and I write this to 16, you're going to notice that it now goes to 0 because 16 has a higher priority. So I'm going to actually do priority 8 here. And I'm going to copy this. I'm going to copy this right here. I'm going to set this default value to, let's call it 80, right? Let's back out, set to 80. And I'm going to go and have this output. Why is it not giving me a default of 80? That's interesting. It should be writing to 80. It's weird. Oh, because it already had a fallback of 0. Okay. That is so freaking weird. Because it locked in. So I'd have to do, okay, here. We're going to have to do it this way. Hold on here. Because we're offline. Fallback. It may not work because it's offline. Like I said, all right, it's not working because it's offline, but that's okay. We'll get an online one for our next one so that it'll work because it's offline, it's not going to work because I'm just working on a database and I'm not working on anything with actually live storing data. But that's what would happen essentially if I wrote to input 16 with 62 or with 0, I would then get 0. If I wrote to 8 with 70, I would then get 70. And if I deleted all those to null, I would fall back to 62. That's how the priority array works. So those are objects in a nutshell. We have binary inputs, also known as Booleans, analog inputs, also known as numerics, multi-state inputs, also known as enums, and binary values, which are the logical version, right? Also known as Boolean writables. And then we have analog values, also known as numeric writables. Those are logical. And then enum point writable, or enum writable rather, which will be known as a multi-state value. And then you have the outputs, which are physical points. Another key point I want to talk to is when we would use these things. So binary values, those are typically on-off set points. Those are things for like turning on modes, turning off modes, etc. Maybe like a chiller enable mode, something like a economizer enable mode. Analog values, those are your typical set points. Those are going to be like your zone temp, discharge air set points, pressure set points, etc. And then enumerated or multi-state values, those are typically going to be things like your occupancy modes, occupancy schedules, your system modes, etc. I just want to check sound one more time, make sure everything's sounding good still. Yep, everything looks like it's good. So that is the not too terribly complex point objects. I hope that as you leave this episode, you now understand the 3 common object types in building automation. You understand when they would be used. You understand what priority arrays are and why we use them. And you understand why there's priority arrays on values and outputs, but not on inputs. This should save you a lot of trouble when you're actually going and working on integrations, because now you'll realize if I see a point that is an AI, it is not going to have a priority array, so it's not going to be writable, or a BI or an MI. And if I see a point that's a BV, that is should be, or an AV or an MV, that should be a set point. And if I see a point that is a BO, an AO, or an MO, that should be a output. I don't see very many MOs typically. I just see BOs and AOs. And I do want to say they will almost always in integrations be called what I just mentioned, AIs, BIs, and BOs, or, whatever, right? AIs, AVs, and AOs, BIs, BVs, and BOs. In your integration point list. You will not see them called Booleans, numerics, and enumerated. I haven't seen that. Maybe someone has, but I almost never see that on equipment integrations. So there you have it, folks. Those are point objects. Apologize for the kind of snafu on the audio in the very beginning. Not sure how that happened. But anything else you want to know, feel free to let me know. I'd be more than happy to answer any questions you may have on point objects. I'll sit around here for just a little bit. I'm going to check LinkedIn and let's see what we got on there. Okay, I see a couple people in there. And I don't see any questions though. Okay, cool. And then I'll check YouTube. I don't see any questions there. Feel free to type whatever you want to ask. I don't know why my eye's bothering me today. And I will answer those. I'll hang here for a couple minutes. If you're running into some funky points, you're welcome, Dr. Timothy. He said, well done. Thank you. Actually, while I wait, what we will do, backnet chiller points list. Let's just grab a random one. Here we go. I don't know what this is going to have in it, but let's share it anyways. Share, screen, window. Okay, share. Let's bring this bad boy up on the stream. Let me grab this guy. Okay. And here we go. Let's take a look. Now you're starting to see it, right? I hope you're starting to see this. So we're going to see, ignore Modbus. We'll do an episode on Modbus in the future as well. I forget so many things I want to do in the future. But you're going to see right here, AV1. And what does it go to? Remote set point. AV2, demand limit. AV3, sound limit. And this is a spare AV for something. Now, what we see right here is these are AVs. So we know these are logical points. Right here, we see BV1, which this is the remote start command. Now, this is going to be interesting because this is telling the unit logically to start, but it is not telling it physically to start. This is kind of a little nuance of integrations that throws a lot of people for a loop because they're looking for a BO to start the device, binary output, right? But they're finding a BV. And that is because, like, I'll go a little bit down the rabbit hole with you. Let me kind of lost this for a second. And I'll get to the questions in the chat because I can't see them right now because I'm looking at another screen. So I'll get to them in just a second. But what happens, kind of give you a sneak behind the curtain, a peek behind the curtain. What is going on is you have this BV and it tells, this is a chiller, right? Yeah. This tells the chiller to turn on. But what happens behind the scenes is the chiller itself has a flow sensor. It has a pump that's most likely interlocked with the chiller. And so it tells, when you tell the chiller, hey, you're in run mode, you're in start mode, which you can actually see, right? 0 is stop, 1 is run. So by the way, since you know 0 is stop and 1 is run, what would you want to do? You would want to go to your integrated Boolean or binary value. You'd want to go into your unit types or your facets, and you'd want to set the false, which is 0, because in Boolean 0 is false. You'd want to set that to stop, and you'd want to set 1 to run. That way it's easier for the person looking at this. And you can see it's a little confusing, right? Remote start stop, but it's actually stop run, and this is called start stop. So you want to go and make sure this matches the actual unit types or facets as much as possible. But what happens behind the scene is you command this on, and then when you command it on, what actually happens is it goes through and does a bunch of logic inside itself, the chiller does, and turns a bunch of things on. And now here we're seeing some analog, and it says analog read only, but we can also see that they're AIs. So that tells us it's read only just right off the bat, right? So if you map these in, you can't do anything with them. Now, this is an interesting one. Condenser fan stage 0 through 14. I don't know what 0 through 14 means. I'd have to read through it to figure out. Maybe that's an array. maybe that's telling us like, what stage are we on? And so if we are on stage 14, maybe there's 14. I don't know. Not sure. So I've got all my AVs and we go down. We've got a bunch of BIs. Can't do anything with these either, right? But we can see that we have our actual sets, right? Our facets or our unit types. So we know when we map this point in how we have to configure it. And let's see, are there any BVs? These are a bunch of codes. So I guess all the writables that we had were at the very top. And so we see we've got AVs and BVs, but no AOs and BOs because we don't actually have control physically of anything that's going on inside this chiller. All of that is determined. Now, here's where that becomes an issue. Let's say you get a funky sequence of operations. Um, and folks, I see your questions. I'll get to them in just a second. So let's say you have a funky sequence of operations, because what will happen when you do a job is you will get a sequence of operations for the chiller. And that should be by whoever purchases the chiller, should be communicated to the engineer. And these sequence of operations in the specification and the MEP set should reflect the sequence of the chiller if you are using an integration. Here's where the challenge happens. You have a mechanical engineer who writes a completely different sequence, or you have a commissioning agent who comes along and adjusts the sequence. No longer can the unit perform that sequence because the sequence that they wrote is actually different than what the integrated sequence is. And this is important for you to know so that you can understand this and explain this. There is nothing you can do to change the sequence on this unit yourself. The actual manufacturer, the mechanic who set this up, they may be able to change dip switches on the unit itself to change the sequence. But short of putting a controller on and manually taking over everything, you cannot go and change the sequence. This is very important as you see more and more smart equipment and application specific equipment implemented on job sites. All right, now I'm going to get to your questions. So let me stop sharing this. Let's take a look. What are some use cases for null? So use cases for null are when there is no value. So typically, when you have a null reading, in my experience, something is wrong because, and this is not always. I want to preface that anything I say to you, I try to avoid absolute terms because I can, or someone else listening to this could probably find a situation when this happened. And they were like, oh, well, this is where the use case was. But typically, if there is a null value um, in a output itself or a value itself, and I'm being very particular to define those, you will see null values in a priority array. That is normal. So you may not write to priority array 1 or 2 or 3. Maybe you only write to priorities arrays 8, 16, 15, and 14. 16 is typically global. 15 is typically system, and 14 is typically local as far as logic goes, typically. And so maybe those are the only arrays that you write to, and everything else is null. But you should not see a null value on your AVs. You should definitely not see a null value on your AIs or your AOs, and replace those with BIs and MIs and whatever. Those having a null in a set point or having a null in a AI, and you typically should never have a null in an AI, and having a null in a output, so I'll just say input and output, those indicate something is very wrong. Something is very wrong if your inputs are reading null, because usually they should be reading bad values, but not null. And then if you have a null in your output, that means something is not connected and working in your sequence and you have a failed state. Let's take the example of a cooling mode. Cooling mode should either be on or off in a simple two-state cooling mode. So there should be no scenario where it's neither on or off. I mean, there are multi-state cooling modes where it's, economizer, mechanical cooling, off, standby, etc. But you should not have a null. If you find a null, that is a key point that somewhere in your program, some logic is broken and something did not fire the way it should have fired as far as logic goes. So hopefully that was clear for you, Matthew. Is there any specific BACnet object to store string text variables? That's a great question. I don't know that off the top of my head. Let me see. I don't recall string variable for BACnet. BACnet data types. There is a string BACnet data type. Let's take a look. There's a BACnet array. An array can take a string. There's BACnet binary. Just looking at all of these. I haven't really run into string. I run into string in properties. I run into string like in device properties, descriptions, things like that. So there is strings that are used for different properties of objects, but I haven't run into a object. And we've done a couple BACnet podcasts about like what is an object, what is a service, what is a property. So there's BACnet objects, like device is an object, and a device may have analog objects, calendar objects, trend objects, etc. And then objects have properties, right? And properties are things like device ID, point ID, etc. Device description, unit type. And then you have services, and services are like who is IAM, read property multiple, write property, COV subscription, etc. I don't recall ever seeing a string BACnet object. Honestly, I might not be remembering it. I know that there are string properties though. Hopefully that helps. Oh, and let me share your question. Is there any specific object to store string text variables? So, all righty. Hopefully that gives you all some insight, helps you all out. I appreciate it. Sorry about the kind of goofy start to the podcast. I don't know what happened to my sound. I do appreciate all you all being here. If you found this valuable, the best thing you could do for us is like and subscribe and hit the notification bell on YouTube, on LinkedIn and Facebook. Share this with your network. Just click share. On iTunes or Spotify, please consider leaving us a 5-star review if you feel like we've earned it. That helps share the show. BAS is a small community. It's a growing community. So anything you can do to help share this with the audience, we get more conversations like we're having today. And we're going to get just better questions and better topics. I do not profess to know everything. I'm constantly learning. Anyone who says they know everything, you should not trust them. But the more conversations we have, the more questions, like that string question, I'm going to go and research that. That's going to be interesting. I'm pretty sure there's a string object, but I'd have to go into AshRay 135. By the way, if you all don't know, let me go here real quick. I'm going to share something with you. AshRay wrappers. There we go. Oh, AshRay standards. And I know I'm not sharing, but I'll show you in a second. AshRay standards. Okay, if you go to this link right here, you'll see every AshRay standard, a read-only version, and you can actually go to the BACnet standard right here, and you can look at the read-only version of the BACnet standard. And you can actually go and read what object types are in there. So you can access this by just Googling read-only AshRay standards. And you'll be able to go and actually see the standards and read through them. So hopefully that helps. All right, everyone, not seeing any more questions. Thank you so much. I appreciate all of you. Y'all are awesome. It'll probably take me a little bit longer to get this up onto the website just due to me cutting out the beginning where it was just a disaster. I definitely will make sure I do an audio check every time because apparently someone came in here and turned a dial. I did figure out what it was. There was a dial turned on my mixer board. So my kids like to get on my computer apparently and go on Roblox and turn my mixer board all the way up so that it's like you're screaming, and then they like to talk in the mic and hurt people's ears. They find it funny for some reason. I don't know. But yeah, anyways, thank you so much. I hope you all have an awesome day and I appreciate you all being here. I will see you next Monday. I'm honestly not sure what I'm going to cover yet Monday. But I'll figure it out. I know I still want to bring my wife back onto the podcast and talk about talent stuff. I need to coordinate that with her. But yeah, I appreciate you all being here. Thank you so much and have a great rest of your